Our teammates are Punpargavi, Prasanna, Praveen Kumar, Priyadarshini, Priya Mahalakshmi. We are from Shriram Engineering College. We are going to present implementation of round robin scheduling. We're going to know about a round robin scheduling. Round robin scheduling is a CPU scheduling algorithm in operating system where each process is given a fixed time slices to execute a cyclic order. After a process uses its time quantum, it moved to the end of the ready queue if it is not completed, allowing the next process to run. This continues until the process finishes execution.
Let's discuss implementing round robin scheduling. This C program implements the round robin CPU scheduling algorithm, which is commonly used in operating systems for time sharing environments. In round robin scheduling, each process is given a fixed amount of CPU time called a time quantum, and the process are executed one by one in a circular order to ensure fairness. The program first asks the user to enter the number of processes and the time quantum. Then it accepts the arrival time and burst time for each process and store them in an array. The remaining time of each process is initially set equal to its burst time. In round robin scheduling, each process is given a fixed amount of CPU time called a time quantum, and processes are executed one by one in a circular order to ensure fairness. The program first asks the user to enter the number of processes and the time quantum. Then it accepts the arrival time and burst time for each process and store them in arrays. The remaining time of each process is initially set equal to its burst time. The process then stimulates CPU execution using a loop, where each process runs for either the time quantum or its remaining burst time, whichever is smaller. After execution, the remaining time is reduced, and if the process finishes execution, its completion time is recorded. Using this value, the turnaround time is calculated as completion time minus arrival time, and the waiting time is calculated as turnaround time minus burst time. The program also prints a Gantt chart to show the order of process execution and display the corresponding time intervals. Finally, it calculates and prints the waiting time and turnaround time for each process along with the average waiting time and average turnaround time. Thus, this process demonstrates how round robin scheduling fairly distributes CPU time among multiple processes and evaluates CPU scheduling performance.
Now I am going to explain the output of the program. First thing, the command vi space filename.c is used. Here the file name is Robin, so robin.c is used. This opens the file in the vi editor where we write the C program for round robin scheduling. Secondly, we use the command gcc space robin.c space -o space robin. Here gcc is the compiler. It converts the C program into an executable file named Robin. Then we run the program using ./robin. Now the program starts executing and asks for output. The number of processes entered is 3 and the time quantum is 2 for this program. Then we have to give the arrival time and burst time for each process. For process 1, arrival time and burst time is 0 and 3 respectively. For process 2, the arrival time is 1 and burst time is 9. For process 3, the arrival time is 3 and burst time is 6. After that, the Gantt chart shows how the CPU is allocated to each process over time. The order is shown in the output screen. The time intervals are also shown in the output screen. This means each process gets CPU time of 2 units in a cyclic order, which is the concept of round robin scheduling. Output table shows process ID, waiting time and turnaround time. The waiting time and turnaround time of process 1 is 4 and 7 respectively. For process 2, waiting time is 8 and turnaround time is 17. For process 3, waiting time is 6 and turnaround time is 12. And finally, it shows the result. The average waiting time is 6.00, that is 6, and the average turnaround time is 12. So, round robin scheduling ensures fair CPU allocation to all processes using time quantum. It is mainly used in time sharing systems. Thank you.